Good day, everyone. I'm still Dread, and welcome to Intellectual Virtual Consult. So, here we have a problem on board to solve. So, we want to differentiate this function, finding the first derivative of the function. So, as you can see, this function is in sequence form. Understand? So, it's given a series where we have a number of terms, then with the sign of continuity, which tells us that there are more terms engaged in the series, but are invisible. So how can we differentiate this? Having known that the techniques of relation we have polynomial method, chain rule, product rule, and quotient rule. All right. So it is very easy for us to suggest that we can use polynomial method of differentiating because this function is already in polynomial form. But however, if we use that approach by differentiating this term by term, we have 1. If we share this one, we have 2 into bracket s plus 2 and so on and so forth. But how can we now differentiate other terms? Having known that there is no end to the function, does that mean that we keep differentiating term by term till the kingdom come? No, it's not done that way. So we have to devise another strategy of handling this problem. So how can we handle this problem? By making sure that the differentiation is entirely completed for all terms that are even at that invisible end of the function. All right, so I will just be giving you the strategy to solve that. Okay, now we all know that this is an endless series and we need to study the behavior of this series. Now we see that the power here is increasing arithmetically provided that the base is constant. So this is tending to be more like a GP because the next term is obtained by multiplying the preceding term by common ratio, which happens to be x plus 2. So this is GP series. All right. I've done mistake. This sequence is a GP because the first term is x plus 2 and the common ratio is second term over first term, which is x plus 2 all squared over x plus 2. And if we simplify it, we have x plus 2. So having done this, we can express the function to be the sum of all the terms till the term located at infinity. And this will drop a kind of memory to us about the sum of GP terms to infinity. So we can express this function as sum of GP terms to infinity. Now, bearing in mind that the formula for finding the sum of GP terms to infinity is a over 1 minus r. Okay, so we have y to be equals to the first term x plus 2 over 1 minus the common ratio, which is x plus 2. So further reduced to x plus 2 over minus into brackets 1 plus x. So this is quite interesting now. So we are able to compress the elongated function to a discrete form so that it will be quite easy for us to differentiate using any techniques that we would like to choose. So judging from the form of this function, it's quite easily suggestible to use quotient rule to differentiate this function. So using quotient rule because the function is expressed in the ratio of x plus 2 to the negative of 1 plus x. So this is the scope we are going to use to do this. I'm just interested in just showing you the scope in which we can tackle questions that come in this form, in an endless form. So using the idea of sum of GP terms to infinity, so bringing our function back to its normal state for differentiation. All right. Okay, guys. So this is virtually the end of our computation. So I'm going to be evaluating your understanding on differentiation by just rendering this work for you to do in your basement. So you can try to just try to differentiate this function using quotient rule and let me hear your response when you are already done with that. So I'll be expecting your comments and your questions rather, and also opinions, be it supportive or contradictory, as towards my computation here, and also from your attempts, trying to differentiate this using quotient rule. So at this point, I'm going to say I love you all. So that's the end of today's section. Thank you all. Thank you all. And once again,